Today we're going to talk about the volume of a pyramid. Over the last two lessons we've talked about the volume of a prism and the volume of a cylinder. So remember that a prism has two identical bases that run parallel. The rest of the faces are rectangles, while a cylinder has a circular base and one big rectangle. So these two are kind of related to each other, therefore their volume formulas are related to each other. So we will be calculating the area of the base and then multiplying by the height. In a prism, the base area could change, but in a cylinder it is always a circle. A pyramid, today's lesson, looks like that. So it still has a polygon for a base. In this case, it is sitting on a square. So the base is a polygon. The remaining faces are all triangles. So you can see that right here. That's a triangle, triangle, triangle. Just like a prism, a pyramid is named by whatever shape is the base. So if it's a square pyramid like the pyramids of Giza, a triangular pyramid where the base is a triangle, so that's a triangular pyramid. A hexagonal pyramid, I don't have one of those to show you, but the base would be a hexagon. So the question is, how does a prism and a pyramid relate? So what if I have a prism and a pyramid that both have square bases and are the same height? How are they related? Well, the question becomes, do you think it's half that volume, a third that volume, a fourth that volume? We have the same base area, the height is the same, but this is definitely less. It's definitely less because it fits inside. How much less? So let's do a little experiment here. First thing we're going to do is I'm going to fill up my prism. So here's my prism filled. And how many times do we think we can fill the pyramid? Say it out loud. Do you think it's a half, a third, a fourth? Can I fill it twice? Can I fill it 3 times? Can I fill it 4 times? Here we go. Try not to get a mess all over our brand new carpet. So there's one. There's 2. So it's definitely not a half. And there's the remainder of the rice. So there's 3. Give or take a few kernels of rice because I lost some, but it filled it 3 times. So this prism filled this pyramid 3 times. So that means the pyramid is a third of the prism. So that's exactly what the formula says as well. Let me get that rice out of the way. See, I told you I lost some. Okay, here they are, out of the way. The volume of a pyramid is 1/3 the volume of a prism. And the volume of a prism is the base area times the height. And remember, this base area is going to change if the base is a square, if it's a triangle, if it's a hexagon, whatever shape it is. So when we look at question number 1, it's a pyramid. So the volume is 1/3 the area of the base times the height. But we want it to be specific to this pyramid. So you'll notice that we have a rectangle. The reason I know it's a rectangle and not a square, there's no congruent marks, or better yet, 4 and 10 are not congruent, so it's a rectangle. So we know the area of a rectangle is length times width, yet we still need to multiply by the height. Now it does look like my pyramid is leaning, which is totally fine. We don't care that it leans, we just care that the height is actually perpendicular to the base, and that's what we have. So in our rectangle we have a length of 11, a width of 4, a length of 10, a width of 4, and then we have a height of the pyramid of 12. Since a pyramid is a third of a prism, you can actually kind of ignore the third and do the multiplication, 10 times 4 times 12, and then in the end divide it by 3. But we know from past experience that multiplication has no order, so you could have divided by 3 at any time. So we get 160 centimeters cubed for the volume of our pyramid. Our last example is that of a regular pyramid. So that is telling me that my base is either a square, an equilateral triangle, a regular hexagon, whereas if it doesn't say regular, the base can be any polygon. Volume is 1/3 the base area times the height. But we want volume specifically for our picture. Our picture is a regular hexagon. So for a hexagon, it's 6 times 1/4 times the square root of 3 times side squared. So all of this is the area of the base, or the area of the hexagon. We still need the height of the prism. So we're looking at 1/3 times 6 times 1/4 times 3 times the side is 10 squared, and then the height of the pyramid is 12. Now we can throw this all in the calculator, but I like to do a little pre-planning. You will notice that 3 times 4 is 12, so I could actually cross that out and do some canceling. So then I would only get left the numbers 6 times the square root of 3 times 10 squared. So that gives me 1039.23 feet cubed. And this is actually approximate, not equal to, because we did have to round. What happens if I don't notice that this works this way? Well, one of the things you can do, again, is do this, worry about the third in the end. So go ahead and do the hexagon like you're used to. 6 divided by 4 times the square root of 3 times 10 squared, and that's the area of the hexagon. Then I'm going to multiply it by 12, the height, and last but not least, I'm going to divide by 3. So you get the same answer. Remember that order doesn't matter when multiplication occurs. You just need to remember that somewhere along the line you're going to divide by 3 and you're going to divide by 4.